Hello, and today we are going to take a look at how to do formula creation in Vasari and Revit families. And hopefully after we do a little sketch exercise, we're going to come out with something that looks a little bit like this without too much heavy lifting. What these are individual loaded families that have just had an energy model applied to them as a whole mass so that it operates as one complete building. But it's built up out of a bunch of little pieces that are loaded families like this, that basically just have two parameters applied to them and a little bit of math. So let's get started, and I'm just going to try and build one of these guys up from scratch. So we're going to start with a new mass family, and what we're going to do is we're going to just take this guy and we're going to start out with a box. Nothing fancy, just a box. And we're going to make a parameter for the height, and we're going to make a parameter for the width. So I'm going to go in there and do, oops, I don't even need that one. We need to start off actually with the height. I'm going to keep it simple first. We're going to add a parameter called, interestingly enough, height. I'm going to make this an instance parameter because I'm going to want to change this a bunch of times. So now that we have a height parameter, we can start thinking about what we might want to do with it. So you've got a height parameter, you can manually manipulate it. Make it higher like that. And if you load it back into a project environment, you can place it, and you could also manipulate its height here. So I've got it here, and I can go 20, whatever. It's not terribly interesting, but let's see what else we can do. Let's say that I do go in and I make this now. Oops. I'm going to make this a parameter that has just the width, just to control that aspect. I'm going to call this width. Width, and also an instance. And let's just control how big that guy is. So if I go and I load this back in, load it into the project, I'm going to overwrite the existing. And let's just say that I have this guy, and now I'm going to make it, where's this parameter? Let's make him 20 feet by 20 feet, like so. And now I'm going to just make a whole bunch of these so I can control them in different ways. So I'm going to use the array tool, and I'm going to make a bunch of these guys. Let's make 6 of them. And I'm actually going to ungroup them because I'm going to want to manipulate these guys individually, and grouping them will put them all together into something that I don't want to do. So I can now go in and I can manipulate these guys individually. I can make this guy's height 40, whatever. I can just manipulate these guys like that. And again, not too interesting yet, but maybe then what we can get into is we can get into these things actually being proportional to each other. So now I can make width and height have some relationship to each other. Let's make, let's make it this way. Let's go and stretch out this face. Let's get a length parameter in here too. And I'm going to put a length parameter that allows me to first of all center this thing, hitting my equal sign there. And then I'm going to make one parameter that actually will allow me to do a length. So I'm going to go add a parameter and do a length. Let's also make that one an instance. And let's make height and length have some relationship to each other. Let's make this a long building, so we can make, like a wide building rather than a tall building. So we can go length is equal to height times 2. So that'll just set up a basic relationship between these two guys. So if I go and I manipulate the height here, we'll see that the width also gets, or that the length changes. And if I load this back into the project, overwrite the values, we'll see that I'm going to start to have some different relationships here between things. These guys that I made taller are going to be taller, and so forth. Well, now how about we get a little bit fancier in here, and since I know I've got 6 of those guys placed out there, maybe I can make some sort of progression so that as they go through that assembly, of pieces from, 1, 2, 3, 4, 5, 6, that there's some sort of progression. Well, then it gets a little bit more interesting. Then I'm going to need to have a numbering parameter. And for a numbering parameter, that's basically an integer. So I'm going to make a, let's call it step, because we have a number of steps that we're going to do. And I'm going to make this an integer parameter. And I'm going to also have it as an instance parameter. And what this is going to do is I'm going to give each one of these guys a number so that it knows where it is in a series. And let's just start off with 2, just to see what it does. And let's give it a simple parameter so that for every step, we're going to have an increase in height of 10 feet. Something like that. Pretty straightforward. So for 2, we have 20. And if I change it to 3, we're going to have 30. So now we can see that 3 is percolating down into height, which is in turn driving length. All right. Now we can load this back into our project. And not much is going to happen right away, except they're all going to get sort of squared away because now they all have the same integer value. So now we can start having some fun with this. They're all set for step 3. Now what if we number these from 1 to 6 now? We're going to get some interesting results. So I go 1, I go 2, 3, 4. We'll just finish these guys off. 5 and 6. Oops, missed him. Like that. Nice linear progression. Every time you add a number, it changes the height and it changes the width in turn too. So what else can we do that's a little bit more interesting than this? Rather than making it something that's a linear progression, we could put in something that's more interesting, like a sine wave function, so that it moves up and moves back down. We're going to see that that's going to create a couple of complications. So let's go ahead and let's start changing the height to be doing something that's a little bit goofier. So in order to do a sine function here, I'm going to replace my height with a sine function. And to do that, we go sine, and then I'm going to have it operate on something. So let's say that we're going to use step, because that's going to be stepping us through our formula. Now, if I just do the sine of the step, it's just going to be times, 1 and 2 and 3. And that isn't going to come up with some very interesting numbers, because sine waves move through a periodic movement through 360 degrees. So we're going to need to do a little bit of work here to get the step moving through 360 degrees. And one of those things to do is that we need to actually get some degrees in here, because if I just left it at step, it would do this, which is inconsistent units. You cannot use the sine wave to operate on a simple number or an integer. It needs to operate on a degree. So I'm going to get my handy dandy character map. There's a number of ways that you could do this, but basically you need to get a degree sign. Sometimes what I do is I add a parameter that's just an angular parameter and scoop out its angle. But here we're just going to go step, and step is going to be multiplied by, let's do this in 30-degree increments maybe. So we can go 30. Now let's do it in something a little less. Let's do 10. And I'm going to do that degree. Now we're still actually going to get an error if we closed out with that, because it's still going to say inconsistent units. Sine needs degrees, but height needs feet. So now we need to add this, and we need to turn this back into feet. So now we've got something that's returning a number. Sine function is just going to return you a decimal value between 1 and -1. So I'm going to go times 1 foot, and what's that going to give me? That'll give me 6 inches. So maybe I want to give it something that's bigger than 6 inches, because buildings are usually larger than that. So let's do 100 feet, say. So now I've got something that's going up to 100 feet. Okay. And now I can also test this out a little bit, see what happens if I go to 4. I get 64 feet. I go to 2, I get 32 feet. And now we can try this out. Load this back into the project. Drum roll, please. And we get something that's probably going to be a little bit different. Yeah. So now you can start to see it's doing something a little bit different, and it's not real obvious yet that you got a sine wave because we've only got a few pieces. So why don't we go ahead and we'll change this into, we'll get more of these chunks to sort of see more of our sine wave coming through. And so I'm just going to select all of these guys, and this is, not like an intelligent array or anything, but this is sort of quick and dirty, just getting stuff done. So I'm going to go up here. I'm going to just give myself another view here too, and look down at it from the top. And I'm going to get my guys here, and I'm just going to copy them out. This isn't even an array. This isn't even a poor man's array. This is just getting it done. Now all these guys are, of course, numbered still 1 through 6, right? So I've got this guy. Step 1. Now I want to turn this into 7 and start moving through the rest of my sine wave. 8, 9, 10, 11, 12. Oops, there. So now we can start seeing this is becoming more of a sine wave. It's going up, it's coming back down again, as a sine wave should. Well, maybe I want to start seeing more of that wave. So now I can actually go back in, now that I've got a little bit more resolution on my form, I can go back in here and I can start playing around with these controls. So I've got a 10-degree step, which means that every time I change this, this is stepping 10 degrees into my 360-degree formula rotation. And one thing that I kind of like to do when I'm messing around with these sorts of formulas is there's this great graphing calculator for Chrome that I use a lot called Desmos that is just opening up here. And what it allows you to do is just, you can enter in your formulas. Sine x, whatever. So sine x, I'm just going to get this, regular wave. So what we can see is that we are moving through our sine wave and got about up to here, right? So if I increase this times 2, it's going to mean that my wave form is going to get shorter and shorter, closer together. So if I go and I increase my step so that I'm not just stepping by 10 degrees, say I step by 20 degrees, I'm going to get a denser waveform. And, this is, I hate to say it, but this is all stuff that we did back in like grade school for trigonometry, and I always have to brush off the old brain cells to get it. Now I think that this is going to cause a failure, and it'll be interesting to see why. So I'm going to overwrite the existing one now that I've got a denser waveform, and let's see what happens. Bam! I lost some. Can't make family 2. And I'm just going to say delete type now for a second just to see what happened. So what happened was I made my waveform denser, right? So that I'm going up and I'm coming back down again, and then all of my guys die. Why do they die? Well, let's undo that for a second. And I'm going to go back over to my family and I'm going to take a look here. So as I now get higher and higher in my numbers, you can see I've got 6 is going up to 130 degrees. But at 9, I'm at 0. And not only that, at 10, I'm at negative numbers. Now, that means that it's trying to push a negative number into my length measurements. And that is not okay. We don't like those sorts of things because you can't measure these things out into negative numbers. So what do? Okay, this is where we can go back into math class again. Now, we could make this, rather than doing just a regular sine wave, that is, as we could see in our math formula, what we're doing is we're going up and down, and then we're going down into these negative numbers here, and we don't want that, right? So let's see if we can flip that over and we can use the absolute value sign. ABS. Ta-da! And now we get the follow the bouncing ball routine, where it's going up and down, and then every time it goes to a negative, it just flips the negative back over so that it makes the bounces rather than going underneath. So let's see. We can do the same thing here, right? Yes, we can. Absolute value. And so we encapsulate that like so. And we see that it percolates through, and now we have nice positive values instead of negative values. All right. Now, there's going to be one more problem that we're going to find, but let's see if we can discover it. I'm going to overwrite the existing values, and it's going to percolate through here, and it's going to make the denser waveform that we were seeing before. And now we still have a problem. So what happened? We lost one guy here in the middle. So, and that was number, what? We've got this guy who is number 8, and we've got this guy who is number 10. So number 9 has some issues. We can go back in, we can interrogate the model, we can find out what happens at number 9. Number 9 goes to 0, which is also not so great, because then we have big solid geometry that is suddenly coming up as nothing, and Revit and Vasari don't deal in nothing, they deal in solids and surfaces. And so now we need to take this guy and we need to deal with 0. So how can we do that? Here is where we get some fun with conditional statements. Basically, we want to say, if this comes out as 0, do something else, right? So we can do an if-then statement. I'm going to grab this, I'm going to copy it. And this is going to look really cumbersome, and then I'm going to show you a way to make it not so cumbersome. So first what we're going to do is we're going to say if. If. And the way that if-then statements are set up is that you say if, and you give a condition, and then you give what you want to do if you meet that condition, and then you say the alternative if that condition is not met. So if my whole formula equals 0, then, and that's going to be a comma, then what I want it to do is, I want you to do exactly the same thing of what that equals, and then I want you to just add something to it, because I don't want 0. I'm going to say 10 feet, because 10 feet is still a reasonable size to have a building, right? So if my sine wave formula equals 0, then what I want you to do is do the sine wave formula, but also add some more information to it. And otherwise, I want you to keep on keeping on and keep that sine wave formula going. So now I've got a much more complicated formula here, but it is also going to be significantly more robust. So I'm going to load this in. I'm going to overwrite all the existing values, and it's not going to do anything with this guy first, because basically it's just following exactly the same rules as before. Except now, if I take this guy, I can go and replace the guy that got blown out before. And now if I change this guy to 9, what we're going to see is that instead of becoming nothing and disappearing, it gets changed into a 10-foot high square. So it's just overriding that 0 so that we don't have geometry that just disappears, because disappearing geometry is no fun. So another thing that is no fun is this whole formula that we have here now, which is large and cumbersome, and it's starting to get hard to manage, because what I want to really start doing is I want to start messing around with this formula and doing other things with it and trying some variations on it. And if every time I have to change, 20 degrees to 15 degrees, I have to change it here, and I have to change it here, and I have to change it here, that blows. So what I want to do is I want to encapsulate that formula someplace else that I can mess with it more discreetly. So what I'm going to do is I'm just going to say, I'm going to add another length parameter, and let's call this my height multiplier. Height multi. And it's going to be another instance parameter. And what I'm going to do is I'm just going to take this formula that I've been working on. Where does it go? It goes all the way out to there. And I'm just going to plop it right down in there. So now I've got sort of another formula in here for that height. And now I can be a little bit more discreet about how this whole formula is set up. And I can just say if height multi equals 0, then, and now I can also just say 10 feet. Because that's what I know it's going to be. That if it's 0, I don't want it to be 0, I want it to be 10 feet. And else, I just want it to be height multi. Height multi, like that. Let's see, did I get that right? Yeah, so it didn't change anything. It just made it a little bit more manageable. So now, the only thing that changed was how I present that formula. So now, if I want to go in and I want to start manipulating what my height is going to be, I can just go and I can mess with this one formula. Well, and there's one other thing that I could do, because maybe what I want to start messing around with is the overall size of the building. So if we look in here, these are pretty big chunks, right? Now I could take all of these guys and I can just select them all, and I can start treating this thing like a building, because that's sort of what we deal in. So let's make 5 floor levels here, and we can start looking at this thing. I can go and I can take my mass schedules, which are right here. It comes built in. And I can look at my floor area. I can see that I've got, 146,000 square feet all the way down here. And maybe that's not appropriate for what I'm looking at. And maybe I want to control all the sizes of these things at once. So what I can do is I can go back to my formula that I was looking at over here, and I can just start isolating variables here. For instance, maybe I want to isolate the 100 feet, which is sort of a big multiplier that I use to drive all this data. So I can add, let's call this scale, because this is going to scale my entire project, right? So, and I'll also call it a type parameter so that I can overwrite everything that's there. So all of these guys are going to behave this. Not just each individual one is going to be manipulated, but I'm going to manipulate the whole scale. And so scale is, again, it's a feet measurement. So what I can do is I can go in here and say, all right, 100 feet, and let's replace this with scale. So I'm starting to abstract out my formula a little bit. So now it didn't change. Whoops, did it not change anything? Scale times absolute value. Okay, yeah, because it's all 0. So let's just take a look at some other values here. So now I've got 100 feet driving the scale, and it's no different really than what I had before, except now I can control this in one place. I can load this back in, and I can control all of my geometry now by that one parameter. So this is going to percolate through, and it's going to think about it, and everything shrinks down. So what does that mean? So if I select one of these guys, we can see I've got an edit type property here, and I've got my 50 feet. This means that I can start affecting all of these guys at once. So I can go, let's look what happens if I do 75. And now the whole assembly is going to scale according to that measurement. And I'm going to get a bigger building like that. So I can start going back and forth with my mass floor schedule. And I can see what kind of effects it has for me to change the scale of the entire building. And that way I can start actually having a little bit of fun with these guys. So now I've got control over the whole scale of my building. I've got all these guys sort of behaving well. Now I can also go back in and I can start doing things like, I can start changing my formula. And this is where I think you actually get the payoff on this sort of stuff. You can start going in and saying, well, what kind of waveform am I looking at? Do I want to do something like 10 degrees? I can take that, and we'll stick with my 50 feet. And I'm going to go and I'm going to load this back into the project and overwrite everything. And now I can start looking at changes in all the building's overall form based on what I have been putting together. All of these things also behave as their own chunks of material, so I can go in and I can start joining them up into one thing. I'm just going to go through and I'm going to join all 12 of these guys into one thing, and I can actually start doing the rest of my sort of building modeling workflow, where I can do things like I can do energy analysis on these guys. So I can go analyze it, and I can enable my energy model. And Shazam, I've got, my whole energy model for my building, which I can send off for analysis. So I can actually start comparing different sine wave formations in terms of overall energy analysis for the building. And I'm going to just undo that because I want to go back. I want to make some more changes. And although I wouldn't even have to undo it really. So I can go back in and let's see, let's do one more transformation on this thing. I'm going to add another parameter, which I like to do this sometimes. I just make this is going to be a place for me to keep formulas. This is the sine formula. And this is just a trick for how to sort of keep information around right here in the parameters. So I've got my sine formula, right? Which is a way for me to do this work. And I'm just going to keep it up here in my text parameter. But maybe I want to try out some other formulas, like, let's just keep this relatively straightforward. I'm going to change this to a tangent. And my recollection is that this works better if it's done in teeny tiny degrees, but let's see. So I just changed my formula into something that's a very different kind of function, and it's going to percolate through here. And you can't really see what's happening with it right now, but we can anticipate a little bit about what's going to happen with something like this if we go back to our calculator and go tangent. Whoa, it's just a completely different thing. We also changed how it was stepping through, so there's some implications to it. So what does that look like when you load it back in and get a different building form? Well, let's see. I don't remember if this is going to blow things out or not, but it's always fun to find out what it's going to do. So it's going to percolate through, and whoop, it's a whole different building form now. And again, you can enable energy analysis on this guy, and it'll percolate. And now you've got another form that you can send off for a different analysis. And then you can start, comparing these wildly different kinds of things, but are still the same underlying building, the same underlying form elements to see what kind of effect they have on things like, whole energy analysis, or whatever you want to do. And it's all, of course, still hooked up to things like floor schedules, so you can see if you're still hitting your target requirements, whatever they might be. Anyway, so you can start playing around with these different formulas once you do this kind of setup and do all sorts of different forms. Really, sky's the limit as far as math-based form creation once you get to this stage. Anyway, I'm going to call it quits at that, and I hope that that was useful and a little bit interesting. Thanks for watching.